Alrighty. Hello, everybody. Thank you so much for coming out today. My name is Ryan Painter. I'm one of the organizers of B-Sides Pittsburgh. And let me say on behalf of the organizing committee, volunteers, staff, etc., we are so elated to have you all coming out to the conference this year. So round of applause. Absolutely. Thank you. I will try not to clap into the mic or scream into the mic. Wow. Okay, so I'm excited to introduce a fellow Ryan as our first speaker for the Black Track today. So Ryan Voloch will be presenting Open Source Adversary Simulation Toolset Review. A little bit about Ryan. Ryan Voloch has 16 years of experience in leading and maturing cybersecurity programs for large national enterprises. With executing major enhancements of 2 security operations programs under his belt, he has considerable experience with improving defenses via maturity assessments, incident response, and red teaming. As a Pittsburgh native, Ryan started his career in retail and in higher education. He's currently working with one of the largest healthcare insurers and providers in the United States. Among many, some of Ryan's passions include blue teaming, maturing processes, and developing people. So without further ado, I'd like to introduce Ryan Voloch.
Thank you, Mr. Painter. All right, welcome. You're at Open Source Adversary Simulation Toolsets. All right, to start off, who knows? Oh. First time with PowerPoint, sorry. Come on. Come on. Slide 2. You can do it. Come on. Who knows what this picture is? No. Goat Simulator, that's right. Goat Simulator. All right. So, why? This is my theme, Goat Simulator. Why? Well, because it's just stupid funny, and I like stupid funny things. And it's interesting, the game could actually simulate just about anything. You could simulate microwave, all kind of different things. It's just very silly. Plus, my 8-year-old really likes it. I probably should have put in there that goats kind of have a like similarity to like evil things, I guess. But anyhow, that's my theme. All right, so agenda today, we're going to go over the goals of the presentation. We're going to talk. We're going to give hopefully a brief adversary and simulation primer. We're going to go through 4 practical use cases or uses of these tool sets. We're going to review 5, not 4, but 5 open source tools. I added one. And we're going to also discuss the future. I know by the way, Goat Simulator actually started out as a joke from the software company. Internet went viral with the video, and it became a big thing. So who am I? In this order, I'm a Christian husband, father, and the manager at HM Health Solutions. I got a few experience, got a few creds. This is actually me in my B-Sides 2017 shirt in Pisa, which was like 5 days ago. Had a great time. First time B-Sides talk. Yeah. So goals. I want to help you understand the practical benefits of adversary simulation and the tool sets. We're going to do a quick review of the 5 tool sets, kind of like a software review. I want to encourage you, the community, to participate and to utilize and participate in the development of these tools. I hopefully am going to entertain both technical and manager levels defenders. So why? I really think these are some important concepts for cyber defense, just based on my experience. There's a lot of new things coming out, like the MITRE attack framework, where we can better quantify, operationalize, and prioritize our defenses through using the techniques in the MITRE attack framework. I think these tool sets are generally not widely discussed in the security community, which is kind of why I want to start talking about them. I learned I really learned a lot through this process, and I wanted to share the practical uses. And I really want to give back to the community. And by the way, I'm by no means an expert. I'm really just a InfoSec guy who just ran through these tools just to learn a lot of things, and I'm just sharing my experience. So throughout the talk, you're going to hear me say a few different words. These words mean the same thing. So when I say adversary, I mean threat group or threat actor or threat group. I may say either one. When I say simulation, it also means emulation. When I say test, it also means a MITRE technique or an attack. So just as you listen to me talk, that's sometimes the terminology that you may hear. So we're going to start off with a quick MITRE primer. Hopefully everybody in this room knows this. There's 244 techniques classified under 12 tactics that classify the latter half of the cyber attack kill chain. We're going to be focusing on techniques today because that's what these tool sets do. Many of you are familiar with the pyramid of pain for cyber defense or of intelligence artifacts. Where as you go up the the pyramid of pain, it gets tougher and tougher as you go up the pyramid. I put at the top adversaries. They might be the toughest part of artifact, I guess, to identify. However, the good news is our controls and intelligence is getting better at TTP mappings, specifically to the MITRE framework. And we're also getting better as an industry with identifying our adversaries. So how do you identify adversaries? There's lots of ways to do that. A lot of organizations, three-letter organizations, three-letter government, EDR tools, MSSP vendors, they're all coming, have a lot of, their databases of intelligence is getting better. There are 86 adversary groups currently published on MITRE's website. So this is an example of an adversary and the information that's available through the public MITRE reference. This is DPANDA. A lot of people know about DPANDA. It gives you some explanation of what the attack group is, and then the techniques utilized and the software utilized, all publicly available. Defining adversaries is tough because it utilizes a concept called technique chaining, which is what I want to kind of focus on, but also in addition to technique chaining, but it's the reviewing the mission and objective of an adversary. But we're going to focus on technique chaining because that's what these tool sets focus on. And this graphic hopefully kind of explains what technique chaining means. As throughout a cyber attack, throughout the kill chain of a cyber attack, an adversary will look like this. We'll use these behaviors, these tactics to identify behaviors. These techniques to identify behaviors. So adversary simulation, why is it so important? What is it? So simulation is emulating the technique chains of an adversary that's most likely to target your environment. So we're not switching to focus on just the TTPs and artifacts. We're switching to looking at all the TTPs combined and looking at the behaviors that are observed in a cyber attack. So why identify and simulate these adversaries? Well, you've heard it said by famous researchers that the blue teams only need to detect once throughout the cyber kill chain. A defender's primary goal should be to increase that probability within that kill chain to detect that attack. Identifying our adversaries allows us to prioritize which techniques and cyber controls we should focus on. There's more information, a lot of great information available on the web. It's a whole nother talk in itself about the process of adversary simulation, but I thought this was a good one to reference. This is just a talk on SANS websites, Attacking the Status Quo, Threat-Based Adversary Emulation with MITRE Attack by Katie Nichols and Cody Thomas. It's a 5 steps of adversary simulation, the process, and we are focusing on that last step here today. So the tool sets, all these tool sets discussed today map simulated attacks to the MITRE techniques. All these tool sets are frameworks that typically include a sample of tests, and the community is encouraged to participate in developing those tests. All these tool sets typically utilize scripts for executing commands on the hosts. Some of these tool sets include binaries, and executables that come with the test. Some of the tests get binaries from the internet to execute. Some of these tests require DLLs or separate executables. My point here, I guess, some of these tests actually include the binaries. Some of these tools include the binaries, some don't. All these tool sets are typically safe and typically include cleanup functionality. All these tools have the ability also to create technique chains to simulate an adversary, or at least define a strategy to help simulate a strategy, or simulate an adversary. All these tools are either locally executed or an agent client-server relationship with an agent that communicates with the server, or through a remote access tool. It's interesting that none of these, or very few of these, actually include adversaries to simulate. So it's very interesting on that. They do give samples. A lot of them do give samples. I still probably wouldn't recommend it running in production environments unless you know the tools really well and what they do. So let's go over 4 practical uses of these simulation tool sets. The first one is supporting purple team testing. So in my definition of purple teaming, summed up in one sentence, the tester says, hey, I did this. Did you see it? And the defender responds yes or no. So adversary simulation tool sets are the primary tool set for purple teaming. Adversary simulation is also known as threat-based red teaming. That means when a red team engagement will pretend to be essentially an adversary and utilize the techniques that the adversaries utilize. So pen testers, I am hearing, starting to consider utilizing these tool sets. One, to help communicate their pen test reports and the techniques that they utilized to their clients. Another use that they're possibly utilizing is assisting the customer, training the customers to utilize these tool sets to validate and test for mitigation and validation post-penetration test. And I've also heard that some are using these tools as a penetration test tool in its own due to some of the automation and variance that some of these tools can provide. We'll talk more about that. The second practical use for these tool sets is to quick test your cyber controls. You really want to answer, hey, did my fancy new EDR, EPP, or MSSP that I just purchased, did it actually detect what it should be detecting? Is it actually working? Is it functional? Some of these tool sets have the ability to just run all the tests within the tool set. Typically, that's fairly easy. Some tool sets do better than others. Useful this is very useful, as I mentioned, useful for testing even new or existing controls. A lot of times, these tools are utilized through technical proof of concepts for security products and services. A useful idea that I thought is to develop a simulated detection report for your MSSP or EDR vendor. Ask for roadmaps for detection for your organization techniques that your adversaries utilize. Another thing that you could utilize for your quick test is testing your SOC for simulating tests and how they respond. Testing also post-test can also help with defining training opportunities within your SOC, identifying which logs and the alert names, and make sure they're intuitive to your analysts. We could also look for improvements in your knowledge bases for those simulated tests. And also, you could also test the manual or automated response triage with those events. The third practical use, is improving your cyber assessment and threat hunting processes. Simulation improves the detection maturity measurement. That's the key, is the maturity measurement of a cyber assessment or a threat hunt process, or a certain threat hunt. If a control detects a simulated test, then the maturity is risen for that specific tested technique. You've seen these are the heat maps and maturity over time. This is a threat hunt technique detection maturity level. So through each technique that is hunted or tested, you could, with a properly simulated attack and detected attack, should put you in a good or excellent 4 or 5, 0 to 5 level. There are many different ways to quantify your hunt. Here's some really good resources that I recommend. Quantifying Your Hunt but Not Your Parents' Red Teaming by Devin Kerr and Roberto Rodriguez. And then Ready to Hunt First, Show Me Your Data by Robert Rodriguez. Really good information about how to quantify your threat hunts and cyber assessments. By the way, I will be providing these copy of the slides at the end, so no need to take pictures. All right, so the last and final practical use case for these tool sets is security product development. It's a key concept for a lot of security software providers like EDR, EPP, and MSSP vendors. They're utilized in, many of these tools are utilized in their QA processes for regression testing to validate their product actually works. So typically it's inserted within a normal QA process for normal software development, ran after changes or a new technique detection functionality is added. Simulation tools are utilized to help improve noise rates, improve relative accuracy, and help with the output that the tools provide. So a simulated test confirms acceptance criteria. It's good. Some EDR and EPP developers that I've encountered actually have a one-to-one test for each technique and function within their development processes. So those are the 4 practical uses. I want to talk about something, there's an issue, a process issue throughout the simulation it's a challenge. It's called, I'm not calling it, it's actually Chris Gates called it closing the alert loop. So what the problem is, after you perform a test, it takes a lot of manual effort after the test is identified to go into your logging system and validate, yep, did my test detect, did it prevent? Yes or no. That process right now, I have not found any open source tool that is able to automate that process. So really the goal of the process to close the alert loop would be to execute and generate that alert after a simulated test is not detected, hands-free. So we want that process to be hands-free. So really the desired process, what we'd really like to help address this issue is for every new technique or intelligence obtained, or when a new test is developed in the community, execute that test, have our logging systems detect and log that system, or controls. It could be an EDR, it could be a SIM, but then the simulation tool would then integrate with that logging source and identify whether that test was simulated, was identified, detected, or not. If it's not, then it sends out an alert. Hey, a test was executed, but not found in your log. So that is something that that some of these tool sets need some help with, and some of them were developed for that reason. All right, so a little bit about the testing methods. What I did, so I just did some research. I installed and ran a certain technique, which I'll talk about, and then I started documenting what I found. Some cases I did contribute to the open source projects. In many cases, I also interviewed the primary project contributor. I utilized Detection Lab, which is a fantastic discovery for me. It has 4 servers, Windows, Linux, actually 3 Windows and a Linux server, included domain. It's got all the really cool lab environment. I also discovered Vagrant, which was a mind-blowing discovery for me. It was super easy to set up a VirtualBox environment with just a few commands, and you got yourself a lab. It was really cool. So we're going to look at, for each one of these, I ran an example technique. This technique actually is utilized in examples through many of these tools. It seems like to be a standard for a lot of the tool sets and how they explain how the tools work. All it is it's a defense evasion execution, another way to execute an executable with bypassing without actually running an executable. So red server 32. If you read anything, read the red, but it's a way to execute something. All right, show you the tools. Let's go. So we're going to go through, I added Purple Team Attack Automation Framework in addition to what you're seeing in the agenda. And the order somewhat shows an evolution of the tools. So starting from earlier developed to kind of very current. All right, endgame RTA. So just a little bit about the format. The highlights is just kind of some points of difference. But I'm just going to talk through them, and I also have some screenshots to show you the tool set. So some interesting facts about RTA. Devin Kerr is the author, our primary author. I actually went to college with him. I know him real well. And great guy. And so he developed this tool out of Endgame, security software product development. And so it is a locally ran framework. There's no agent, there's no server or remote access tool. It's runs off a Python core, which is simply just Python scripts. The tests do include the binaries and executables, and what's nice about it, it's pretty simple. But again, it came out of Endgame. Product development was really one of the best uses for this tool. Here is some, I think it's a Python code for this test. And you see there the reg server 32. You're going to see this line in several of the example codes that I show you. Very similar commands are executed. You'll also know some cleanup there, and whether or not, if the task, this framework executes Notepad upon a successful test. Some other ones execute calc by default, but this is all changeable. It's scripts. But this is the YAML. YAML's no, you know what? That's Python. The next tool is METTA. This was authored by Chris Gates, who out of Uber. This probably could have been the first popular tool of its kind, given that the fact that it ran as an agent. Specifically, the biggest difference of METTA is its architecture. It utilized somewhat of actually a client-server relationship, but it utilizes Vagrant, which is very interesting. The reason why it was developed was to help Uber's security team close the alert loop, really trying to automate that detection and reporting in one without any manual intervention. It is Python-based. It runs off a Redis Celery server. Adversaries are simulated through a scenario of scripts of many actions. And the executables are not included, but I believe they are typically downloaded as a test is initiated. As I mentioned, Vagrant's required. Vagrant is the rat. And very good for cloud infrastructure as a service because it supports Vagrant. A lot of the practical uses for improving your cyber assessment and hunting programs, just because it was intended to close that alert loop. So the architecture, again, is the biggest difference with this tool set. So you got your METTA server at the top, which works and issues and integrates with Vagrant to issue commands down to each of the hosts in your VirtualBox or VMware environment. Here's some screenshots. On the left-hand side there is the configuration and the integration with your Vagrant hosts. So you list your hosts, and then you list your location of where your Vagrant scripts and files are located. And on the right is a YAML file. I think YAML is not your markup language. It's a very readable type of markup language. And there you see command exe with reg server 32 and a reference DLL. Very similar for T1117, very similar execution from the first framework. But you also see other in the code, you also see other information, literally meta information. In the code, you have the reference to techniques, descriptions, some decent information. Here's an execution of this is actually not the execution of T117, but this is an execution of just a YAML file that's called onTarget that just runs a bunch of net user, net view, net group commands, and just runs it on the box. And here is a report of the output of that command and the commands that were ran. There it gives you the time and the action. The other thing that's interesting about METTA is that they did build a Slack integration to help close that alert loop to integrate with other tools. All right, Atomic Red Team, next tool. So, Atomic Red Team was developed out of Red Canary. Primary author there is Casey Smith. It's not necessarily an execution framework for executing tools, but it's more known as a library, and the largest library of the tools available. I'm sorry, the tests available. They do have execution frameworks. There's PowerShell, there's a Python tool, and there's a Ruby tool that allows you to execute these tests. The real benefit for these is that they're simple and they're atomic. They run within themselves. There's really no other binaries to download. You just run the tool. Some of these, as you notice there are 483 tests, but 182 covered techniques. So that means that there are multiple tests per technique. And you'll see in the screenshot next of me running the Invoke Red Team execution framework for out of PowerShell. Adversary simulation is manual. Once again, they have a sample script. They call it chain reactions. But I think really all they are is just scripts to put tests together and make decisions. I mentioned there's the largest repository out there of tests, and I'm pretty sure the reason why they've had so much support from the community, because their documentation and their framework for including the community is very, very well done. It's very organized and very good. I guess they give really good guidance to how the community can support them. Very good processes there for testing and for inclusion if you want to develop a test. They really want the community to help this framework, because this framework is utilized in other open source frameworks. This is a very good tool to quick test your cyber controls, but it does support all the uses of adversary simulation toolsets. Here's a little bit about Atomic Red Team and its framework. It really is just a zip file. You export it, and you have a bunch of folders that include your tactics. And inside each tactic folder is a MD and a YAML file. And then you also see a binary there. Here's an example of T117 being executed through the PowerShell framework. You see there that there are 3 tests executed in its output. I believe this is a verbose output. But 1, 2, 3 of 3 for this test. In my lab, I'm still not quite sure why Calc only executed 2 out of the 3 times, but hey, it worked. I was really happy with the output. Here's a little bit of some code. Every technique is very well documented, and every test is pretty well documented as well. So up the top is just a summary of what this test is, and at the bottom is test 1, 2, 3, a little bit about each test that's ran within that technique. I'm pretty sure there's a way to execute a specific test within a technique. I just didn't get there. So here's actual code from Atomic Red Team. There's your command. But also have, this is the YAML file. Again, a lot like METTA and its YAML information. Gives you some information about the technique, executing the test, description of the test, and that's one of the 3 tests within that YAML file. And I really like the documentation on the wiki as well. That same documentation is available also on the Git wiki page for Atomic Red Team. This is a little bit showing a little bit about the chain reaction scripts. Again, they are just simply scripts executing multiple atomic tests. And the thing about adversary simulation is it requires decisions to be made throughout testing the cyber kill chain, but these decisions would have to be manually scripted if utilizing Atomic Red Team. All right, CALDERA. This is probably one of the most exciting frameworks. So we're getting more exciting as we go along through the framework, through these tool sets. So CALDERA was developed and supported by the MITRE Corp, specifically David Hunt. His team are really wanting this tool set to be a framework for automated red team operations. They want to automate the testing, focusing on post-compromise tests. There is a 2.0 version. The screenshots you're going to see are the 1.0 version included from the detection lab. I just did not get a chance to do try out the 2.0. But functionality, they want, it's a GUI, typically GUI. It's point and click adversary simulation. They want to make it very easy to install, very easy to use. They want to bring your own technique. They want that capability. Actually, they have that capability. They don't want programming experience required. They have a new open plugin architecture that's released in the 2.0. You get to bring your own RAT or client-server relationship tool, or how you execute commands on a host. You could do that in multiple different ways. There's also some very smart planning capabilities through artificial intelligence, which is really, really cool. Supports multiple OSs. I think this is the most mature open source framework I've seen. However, the development activity on CALDERA is very high. And it's a good thing because they're making it better. But the 2.0 and 1.0 are very, very different. So just know that. MITRE is certainly supported because obviously it came from MITRE. The best practical use is the support purple team testing. So you would have this installed in your environment and probably in a dev environment to test your cyber controls and improve and assess and performing threat hunts utilizing this framework. But a majority of the best practical use for this tool is actually supporting the process of adversary simulation. So the adversary is simulated there. You've seen that I have some numbers there. I put variable for this one because it is like a point and click of defining your adversary. To make it really easy. Where other tools utilize scripts to make decisions, this tool, it's point and click. It's really nice. Reporting's very good GUI as well. All right, so CALDERA, it was originally developed by the defenders, but David Hunt and the MITRE team have been really pushing and utilizing into their offensive space, which is really cool. If you want to learn more about CALDERA and the 2.0 version, there's an article by David called Automated Adversary Emulation. I'm sorry, it's a YouTube video. Automated Adversary Emulation available. It's a very good run through this tool, very technical of the version 2.0. So here we go. This is CALDERA 1.0. This is now known as the legacy interface. And again, I just didn't get a chance or time to, because the 2.0 version was recently published. But it works very similar. The concepts you're going to see are very similar to the 2.0. Here's your point and click adversary definition. You see there you can select which techniques you want to add in your adversary. I titled my adversary Bad VDOG ATP123 just to play with it. Then you can just point and click and select which techniques that you want to utilize throughout your test. Successfully executing the test looks like this. This is a visual of a compromised network. Each of these hosts within my lab environment had the CALDERA agent on it. The 1.0 does have an agent, but also, and that agent will then execute whatever test is on that system. But this is just showing a properly compromised network. I believe that's after an attack is executed. So 2.0 notable features. I think I mentioned that the new version has a new Python core control center. And I think one of the coolest things of this tool is the ability to automate planning and intelligent technique chaining. It's super, super cool. It utilizes AI scoring for the next technique chain. So throughout the technique chain, it could, depending on what techniques that you want to simulate through your adversary after you define an adversary. The definition and how it decides to do which technique next is super smart, and it's kind of scary in a way. You also have the ability to define your own logic to how you want your technique chaining to work, or your next your decisions that are made. Very, very cool stuff. It does support bring your own technique. It does support the atomic red team framework and all 483 tests. You could bring your own remote access tool. What comes out of the box is a rat called SandCat, and utilizing there's some other plugins with Caldera that are really cool. I believe the intention of this is to help the plugin. One of the intentions is to help close that alert loop. Hopefully someday there will be a plugin that does that. Okay, and finally, the last tool set that we'll talk about today is the Purple Team Attack Automation Framework. It is one of the newest open source adversary simulation tool sets out there. It was just recently released, very new. It's pretty simple. If you know Metasploit, it's a clone of Metasploit that includes references to post-exploitation modules as tests. The RAT, or the client-server relationship, actually is a interpreter shell. So you have to get interpreter to execute on your host, and then it communicates with your client MSF shell or instance. And but really, the best practical use for this is to support purple teaming testing, because the Metasploit is more of a red teaming tool. I feel like it's easy for a penetration tester to help with that. Improving the cyber assessment and threat hunting processes. It does have 100 tests that comes with it out of the box, but it doesn't really do adversary simulation. But I still think it's pretty cool because it utilizes Metasploit and Interpreter. So here's some examples of Metasploit. And when you do a search on Purple, it comes up with all your test techniques. See, they're categorized there by your MITRE techniques. There's T1117. And then here is an example of an interpreter session. I think it's a reverse TCP shell connected to your Metasploit console. That is required for this. And here is, once you are connected with a session, you can utilize and use a certain technique. You just list out the technique. You notice there that there's some cleanup there. You could set cleanup flags, the yes or no, whether or not you want to clean up the files that are left there. But there's your execution of T117, reg server 32, DLL, and then on a certain interpreter session. And you can notice that it found calc and it's running it, and the test was successful. So this framework actually identifies whether calc was actually ran or not, which is a good function. Okay, let's talk a little bit about the future of these tools. These are kind of what I'm seeing these tool sets may do, and it's just kind of some thoughts. You know, we have 75% coverage of tests right now. We're starting to near, I guess, of all the 244 tests, we're about 75% covered of tests able to be simulated. I'm going to see, I know there are some tests and techniques out there that, there are some techniques out there that are just not testable due to the technical nature or non-technical nature of each test. But we're starting to near 100% coverage of all the testable or simulatable attacks. I know that there's commercial software out there. I didn't do any research, so if you have any questions about commercial software, I just don't know. But we're going to probably see more of that. I think we should also see closing the alert loop fixed and automating that through the future versions of these tools. Also would expect to see some integration with some commercial or public intelligence feeds that include adversary behaviors and identify adversaries. I think we are all seeing a better adoption to MITRE attack techniques and TT technique mappings within security products. So when a certain, for example, an EDR product, when a certain technique is identified, that the output of that technique, that T1117, would be in the output of the log. That way we would be able to close that alert loop. We're going to see increased adversary. I expect to see increased adversary simulation functionality within security products, possibly within themselves or possibly like a side tool to test their own stuff provided to customers. I don't know how much you would trust that, but it's a possibility. I also expect to see the ability to emulate and simulate manual non-technical techniques within a tool set. I'll think with a lot of the scriptable tool sets that's fairly easy to do. You just have to do some scripting. But I haven't really seen the ability to, if you want to do a fish test, for example, or do something in the middle within the technique, cyber kill chain, there's not really a spot to do so. It's just more manual. I'd like to see more, I think I expect to see more and more consultants and service providers to provide simulated hunt assessments or threat hunting utilizing these tools. I also expect to see penetration test tooling, possibly like Purple Team attack automation, to include MITRE references, and more tools like Purple Team to include that capability, and possibly the functionality to test whether or not, or to integrate with a SIM or EDR out of the box to close that alert loop. I know there's some concerns regarding for some tooling, like EDR vendors that actually develop detection alerts and techniques from their tool sets that only catch simulation tools being executed. So be on a lookout for some products that only look for the tests that run within these simulation tool sets, specifically Red Canary, just to get a higher rating on their software, through third parties and such. All right, that is my presentation. Thank you very much. So we have a few minutes. Does anybody have any questions or comments? No questions or comments? Yes? Useful for what?
Like your environment.
In my environment? Well, my environment is so the question is, which tool set do you believe works best in my environment? And it really depends what you want to do. I think Atomic Red Team was a very simple one that many people can utilize and execute. They actually have a script within Atomic as a script that runs all tests. I did provide some feedback about that script, about initiating delays and output and the time, so you can run all the tests and then go back into your SIM or EDR and go look at later. I typically think Atomic Red Team is a fairly good place to start. Yep, you're welcome. Any other questions? All right, thank you so much. Enjoy the rest of your day at B-Sides Pittsburgh.